Now here we're going to use ways of solving systems that we'll actually use. I mean, it's nice to say that the lines intersect or parallel or overlapping, but actually graphing lines to find the solution is a terrible method. I mean, okay, I'm listing it, but it really doesn't work because the accuracy of your answer is limited by the thickness of your pencil and the steadiness of your hand and the wood grain in the table. This isn't math, it's carpentry. However, there are methods that are exact and always work. There's a method called substitution, and there's a method called eliminating variables, and there's specialties versions of it for matrices and for Cramer's rule. We'll eventually get to this, and in fact, Cramer's rule is an extra credit set in the modules. It has the virtue of being what's called a closed formula. You just plug in the numbers, turn the crank, and out comes the answer. These rest, you actually have to do some algebra and some thinking. This economizes on thinking, and I strongly recommend that you economize in thought whenever feasible. Now, to solve an equation by a system by substitution is, okay, a couple of steps. We use one equation to solve for x or y in terms of the other variable. Now we use that to substitute into the other equations and get one equation and one unknown. This we solve and substitute back and get the other variable. So for example, you have x plus y equals 10 and x minus y equals 4. Now I already established that 7 and 3 solve this system, but let's find it. Let's find that solution. If x plus y equals 10, then by a bit of algebra, y equals 10 minus x. We just transpose the x. So here's y in terms of x. Y equals 10 minus x. Now we substitute this value for y into this equation here. So x minus y equals 4. So x minus this, 10 minus x equals 4. Now we have one equation and one unknown. So, okay, so we proceed to solve it. Distribute the negative sign throughout, so you get x minus 10 plus x equals 4. Add 10 to both sides, so you get x plus x equals 4 plus 10. So therefore 2x equals 14. Divide both sides by 2. X is 14 halves, and x is 7. Good. Now to find y, you plug in 7 in for x into this equation. Y equals 10 minus 7, and that's y equals 3. And there you go. 7 by 3 is the solution to the system. A handwriting request, a legibility request. When you get an answer, please put it in one spot and, circle it or something. It doesn't do to have x equals 7 in one corner of the page and y equals 3 in the other corner of the page, because you might forget to write down one of them, for example. It's just good form to write the answer definitively and clearly, because clarity is what you're really after in math. Now, the solution by substitution is okay. It has some drawbacks. It requires that at least one of these coefficients be plus or minus 1. That's not always the case. Solution by elimination is much more systematic, and in that sense easier. It involves using row operations to eliminate variables. Now, a row operation starts from a pair of equations, a equals b and c equals d, and then either combine or rescale. You combine equations by saying here, a equals b and c equals d, you write a plus kc equals b plus kd. So each of these plus k times each of these. They should also be an equation. Rescaling is taking a equals b and multiplying both sides by k. Ka equals kb. So the idea is to use these combining and rescaling to eliminate variables, to make variables go away. For example, we're going back to x plus y equals 10 and x minus y equals 4. We already know that 7 by 3 is the solution. Okay, to eliminate variables here, we could add equations, and then y plus negative y will make it disappear. If we add equations, you get 2x here, no y here, 10 plus 4 is 14. 2x equals 14. Divide throughout by 2, x equals 7, and you're done here. Now, to solve for y, we could take these equations and subtract equations. Take this equation and subtract all this. So x minus x, poof. Y minus negative y is 2y. 10 minus 4 is 6. So 2y equals 6, divide both sides by 2, and y equals 3. So again, we have 7 by 3 as the solution. which we got before. Now here is a system. 5x plus 2y equals 11, 7x plus 6y equals 9. Notice that none of these coefficients are 1. So solving for y in terms of x or x in terms of y will inevitably have some annoying fractions. And, ugh, fractions are annoying. But here's what we're going to do. We're going to rescale these equations so that the y's line up. We have a 2y here and a 6y here. So if we rescale this throughout by 6 and this one throughout by 2, we get a 12y in both, which we can subtract away. So 5x plus 2y equals 11, rescale by 6, you get 30x plus 12y equals 66. Here's 7x plus 6y equals 9, rescale by 2, so you get 14x plus 12y equals 18. Now we have a 12y here and here. We can eliminate it by subtracting equations, by combining with a subtraction. So we'll take everything in here and subtract the things here. So 30 minus x minus 14x is 16x. 12y minus 12y, poof, we've eliminated a variable. 66 minus 18 is 48. 16x equals 48. Now all we have to do is divide throughout by 16. X equals 48 over 16. And x equals 3. And we have the answer. Now for the y, we want to eliminate the x's. We have a 5x here and a 7x here. So let's multiply throughout by the other number, by a 7 and by a 5. And these will both be 35. So this first equation, rescaled by 7, is 35x plus 14y equals 77. The second equation, rescaled by 5, is 35x plus 30y equals 45. Now we have a 35x here and here, and we can eliminate it by subtracting equations. Take this equation and subtract everything from this. 35x minus 35x, poof, gone. 14x y minus 30y is negative 16y. And 77 minus 45 is 32. Okay, to isolate y, we divide throughout by negative 16. Y equals 32 over negative 16, so y equals negative 2. And here's the solution. Y equals 3. So x equals 3 and y equals negative 2. Now here we have a real annoyance. Lots of annoying fractions. Ugh, well, a third x minus 7/6y equals a half. A fifth y equals a third x plus 7/15. Ugh. But what we'll do is we'll rescale so as to turn everything into integers. Makes it a lot easier to work with. So we have denominators 3, 6, and 2. The lowest common multiple is 6, so we'll rescale by 6. We have denominators 5, 3, and 15. The lowest common denominator is 15, so we'll rescale by 15. Multiply this throughout by 6. A third x times 6 is 2x. Minus 7/6y times 6 is minus 7y. A half times 6 is 3. 2x minus 7y is 3. A fifth y times 15 is 3y equals a third x times 15 is 5x. 7/15 times 15 is 7. Okay, at least now 2x minus 7y equals 3. 3y equals 5x plus 7. At least this is all with integer coefficients. That's nice, but it's not in the right form. Here 5x is on the right side of the equation, so it's not the usual form for a 2-by-2 system, but that's fixable. We'll transpose the 5x by subtracting from both sides, and here we get this 2-by-2 system. 2x minus 7y equals 3 from here, and minus 5x plus 3y equals 7 from here. And now we can do some elimination of variables. To solve for x, we'll need to match up the y's. We have a minus 7y and a plus 3y. So let's multiply by a 3 and a 7, always a cross multiplication. 2x minus 7y equals 3, rescaled by 3 is 6x minus 21y equals 9. The second equation rescaled by 7 is minus 35x plus 21y equals 49. Now here, it just so happens that this is a plus minus 21y and a plus 21y. That's those here we can eliminate by adding. Up here, we were eliminating variables by subtracting. It comes to the same thing, really. So we add equations. 6x plus negative 35x is negative 29x. Minus 21y plus 21y cancels. 9 plus 49 is 58. Minus 29x equals 58. You divide by negative 29, you get x is negative 2. Now here, if we want to solve for y, we have to eliminate the x's. We have a 2x here and a minus 5x here. So let's rescale by 5 and by 2. Well, we'll get a 10 and a minus 10, which we'll again eliminate it by adding. So the first equation rescaled by 5 is 10x minus 35y equals 15. The second equation rescaled by 2 is minus 10x plus 6y equals 14. All right, 10x and minus 10x will eliminate by adding. So we add the equations, x goes away. Minus 35y plus 6y is minus 29y. 15 plus 14 is 29. All right, and we divide by negative 29 and get y equals negative 1. And there is your solution, negative 2 by negative 1. All right, now let me double check what we have here. Well, we have pretty much a lot more of the same thing. Oops, where was I? Right. Okay. X plus y equals 6, x minus y equals 2. If we add equation, get 2x equals 8, so x is 4. If we subtract, x minus x cancels. Y minus negative y is 2y. 6 minus 2 is 4. Divide by 2, y equals 2. X equals 4 and y equals 2 is the solution. Now here we have y equals negative 5x, x plus a half, 2x minus 3 halves, y equals 5. You know, I could use this first equation and substitute into the second and get an equation with lots of gnarly fractions. No, thank you. So what I'll do is I'll rescale this one by 2 to eliminate these denominators, and rescale this by 2 to eliminate this denominator. We'll get 2y equals negative 5x plus 1, 4x minus 3y equals 10. And then to get it in the proper form, we'll add 5x to both sides to transpose this 5x to the left. And here we get this system. 5x plus 2y equals 1, 4x minus 3y equals 10. So all right. So rescale, we have to eliminate y's, we have a 2y here and a minus 3y here. So we multiply by a 3 and by a 2. So 5x plus 2y equals 1 rescaled by 3 gets you 15x plus 6y equals 3. 4x minus 3y equals 10 rescaled by 2 gets you 8x minus 6y equals 20. Now if we add equations, the y's cancel. We'll get 15x plus 8x is 23x. Y's go away. 3 plus 20 is 23. So 23x equals 23. So x equals 1. Now to find y, we want to eliminate x in this system. 5x and 4x, so rescale by a 4 and rescale by a 5. Was the other coefficients, so they come out the same. This rescaled by 4 makes 20x plus 8y equals 4. This rescaled by 5 is 20x minus 15y equals 50. Now we have a 20x here and a 20x here, so we subtract. X's go away. 8 minus negative 15 is 8 plus 15 is 23. So 23y. 4 minus 50 is a minus 46. So 23y equals negative 46. Divide by 23 and get y equals negative 2. And here's the solution. X equals 1 and y equals negative 2. Here's where trouble comes in. We have this some nasty fractions here, nasty fractions here. Rescale by 3, rescale by 4. 3x equals 11 minus 2y. 4y equals 11 minus 6x. Do some transposing. 3x plus 2y equals 11. 6x plus 4y equals 11. So far, so good. Now let's see. To eliminate the y's, we have a 2y here and a 4y here. I'll multiply throughout by a 2 here and by a minus 1 here. That will get a 4 and a negative 4. The first equation rescaled by 2 is 6x plus 4y equals 22. Second equation rescaled by -1 is minus 6x minus 4y equals minus 11. Now, all right, we can eliminate the y's easily enough by adding, but when we do that, it goes a bit too far. The x's get eliminated too. We get the equation 0 equals 11. Now, hold on. Does 0 equal 11? Someone tell me, yes or no? No, you're shaking your head. Good, yeah, you're right. 0 is not 11. In the before times when I was actually in front of people physically, at this point, I would put my hand in my pocket and turn it inside out and say, damn, there was nothing in there before and there still isn't $11 in there now. That trick never works. So yes, 0 equals net means it's impossible. So there's no solution. This an absurd conclusion, therefore it had its absurd assumptions. There's no solution and the lines are parallel. Here we have similar thing. X plus 3y equals 6, y equals negative a third x plus 2. Well, again, an annoying denominator of 3, so we rescale by 3. So we have x plus 3y equals 6, 3y equals negative x plus 6. Move the x over to the other side. X plus 3y equals 6 and x plus 3y equals 6. By golly, the same equation twice. If you subtract them, you get 0 equals 0. Tell me, does 0 equal 0? Yeah, I see you're nodding. Yes.
Yeah.
Yeah, it is. But tell me more. 0 equals 0. What does it say about x? What does it say? What does it say about y? I mean, does it even mention
Nothing.
x? It says nothing. Nothing whatsoever. No information. So, okay. No information about x. No information about y. So therefore, many solutions. The lines overlap. All right. Now, from 3, 2, okay. Here we have y equals 3x and x plus y equals 8. For this one, since we have y equals 3x, we can already do a substitution quite simply. Where there's a y here, replaced by 3x. So x plus 3x equals 8. One equation and one unknown. And we simplify. 4x equals 8, x equals 8/4, which is 2. And substituting back here, y equals 3 times 2 is 6. So the solution is 2 by 6, as in here. Here we have x plus 2y equals 6, 3x minus y equals negative 10. Now I can use substitution, I can use elimination. You have choice, and this time I'm choosing to use substitution. If x plus 2y equals 6, then x equals 6 minus 2y. That follows directly. We'll substitute this x here where the 3 is, where the 3x is. Let's get 3 times this, which is x, minus y equals negative 10. 3 times 6 minus 2y, all that minus y is negative 10. One equation and one unknown. Distribute the 3 throughout this parenthesis. Get 18 minus 6y minus y is negative 10. Let's transpose the 18 to the right by subtracting. Let's get negative 6y minus y equals negative 10 minus 18. So that means negative 7y equals negative 28. Divide both sides by negative 7. So y equals 28, negative 28 over negative 7, that's 4. And substituting in 4 where the y is here, x equals 6 minus twice 4. 6 minus 8 is negative 2. And so the solution is x is negative 2 and y is 4. Okay. Here we have another case where it's difference is one thing and a sum is another, and it's pretty easy as before. Since a minus y and plus y, we can eliminate y's by adding equations. Get 2x, no y, equals 18. So x equals 9. And then we could subtract equations. X minus x goes away. Minus y is minus 2y. 7 minus 11 is negative 4. So negative 2y is negative 4. Divide both sides by negative 2 and get y equals 2. Solution is 9 by 2. Okay, this one gets gnarly. 2 times a plus b equals 94. 4 times a minus 9 equals 3b minus 23. Oh boy. Okay, first I'm distributing. Distribute the 2 over these terms, the 4 over these terms. Get 2a plus 2b equals 94 from here. Here we get 4a minus 36 equals 3b minus 23. Now for the second equation, let's move the 36 to the right and the 3b to the left by adding 36 to both sides and subtracting 3b from both sides. So first equation, 2a plus 2b equals 94. Second equation, 4a minus 3b equals 13. All right, here we go. All right, to eliminate, say, the a's, we have a 2a here and a 4a here. So times 2 and times 1 will line them up to a 4. This equation rescaled by 2 is 4a plus 4b equals 188. This equation is 4a minus 3b equals 13. Okay, the a's are lined up, so we can eliminate them by subtracting. 4a minus 4a, poof, goes away. 4b minus negative 3b, that's 4b plus 3b, or 7b. And 188 minus 13 is 175. 70b equals 175, divide by 7, b equals 25. Okay, great. To eliminate the b's, we have a 2b and a minus 3b here, so let's times a 3 and times a 2. This equation rescaled by 3 is 6a plus 6b equals 282. This equation rescaled by 2 is 8a minus 6b equals 26. 6b and minus 6b will cancel when we add, excuse me. So we add equations. 6a plus 8a is 14a. 6b minus 6b cancels. 282 plus 26 is 308. 14a equals 308. Therefore, a equals 308 over 14. That's 22. So the solution is a is 22, b is 25. Here's another monster. Denominator is 4 and 5 here and here. Here's a 4/5. All right. Lowest common denominator is 20. So we scale this one by 20. You have a denominator of 5, so we rescale by 5. Multiplying throughout by 20, you get x fourths times 20 is 5x. 1 times 20 is 20. Y fifths times 20 is 4y. Here we scale by 5, you get 5x equals 4 times y plus 10. So we distribute the 4, 5x, and then transpose the 4y left for here. So 5x minus 4y equals 20. Distribute the 4 here. 5x equals 4y plus 40. Move this 4y to the left. So we get first equation is 5x minus 4y equals 20. Second equation is 5x minus 4y equals 40. And already you can see we're heading into trouble. 5x minus 4y is trying to be two different things. If we subtract the equations, everything cancels out on the left. On the right, get negative 20. And the equation 0 equals negative 20. And again, that's absurd. So the absurd conclusion, therefore absurd assumptions, therefore the original system had no solutions, and it graphs as parallel lines. Now, here's the last final one. Here they get cute. 1 over x plus 1 over y equals 5/6, and 1 over x minus 1 over y equals 1/6. These aren't exactly whole numbers. I mean, these aren't, this isn't a linear system, but we can turn it into one. Because if we call 1 over x the name u, and 1 over y the name v, then you right away get u plus b equals 5/6 and u minus b equals 1/6. Okay, that we can solve by the methods I mentioned before. By adding equations, you get 2y equals 1, so u equals half. By subtracting equations, you get 2v equals 2/3, so v equals 1/3. But we weren't asking after u and v, we were asking after x and y. Now let's go back to here. If u is the reciprocal of x, then x is the reciprocal of u. Similarly, if v is 1 over y, then y is 1 over v. So, having gotten u and v, we find x and y. X is 1 over u, so it's 1 over half, that's 2. Y is 1 over v, which is 1 over a third, that's 3. So the original system has a solution 2 by 3.